as Hugo gave an extremely good introduction to that, so I'll talk mostly on the global emissions. So, yeah, I need that. So, as you can see, we developed a lot of different data sets at the global scale, so they are all called CAMS Globe something, as part of the previous contract that finished last year, and that will be further developed in the new contract. So as Hugo said, we started last week. So I will show mostly what is available, what are our plans, and something that you should know that all these most recent versions of the data sets are available only on the ECAT database, and you have the link here to get this data. And I won't talk about the one in blue, the termites, because we developed the data set and we don't plan to do any update on this one. So first, the CAMS Globe on, so CAMS Global Anthropogenic Emissions. The most recent version is 5.3. It has been used a lot by many different groups outside of CAMS. We have more than 500 downloads so far. And so the way we do it, because this data set has to be used for both reanalysis starting 2000 and for the forecast, so you need to have emissions up to now. So we do a combination of different data sets. I won't go too much into details, but some of them provide different resolution, different information, and so on, and different years. So we put all that together, we extrapolate, and we define also different sectors that are consistent, consistent with the CAMS reg that Hugo just mentioned. And we use a ship emission from CAMS Globe ship and temporal profile for CAMS Globe tempo. I'll come back to that. And we provide emissions for many different species, including greenhouse gases and different speciated VOCs for about 20 sectors, and we have publication in preparation. So what are the plans? So the plans were discussed a lot yesterday morning, and so we plan to develop a new version, version 6, using the most recent version of this EDGAR dataset developed by JRC in Italy that was released 1 or 2 weeks ago. We plan to develop that before the end of October, November, but we still need to discuss further with ECMWF and CAMS 235. For example, the first thing we will look at is really improve the SO2 emissions, which are currently overestimated in the data set. But also we need to discuss more how we do improvement and better definition of the emission for different regions and sectors. We will also implement the COVID adjustment factor. So Hugo showed the work done at the European scale. We have also a data set that was published last year at the global scale, and we will insert that in CAMS Globe ANT. We will extend, obviously, the data set for 2023 for the global forecast, and we will also implement a more consistent version of the ship emissions. I'll talk about that later. So first, the CAMS global temporal profiles called CAMS Globe Tempo, developed by Mark and his colleagues in Barcelona. And it's a collection of gridded monthly, weekly, daily, and hourly temporal profiles for different sectors. It covers 20, oops, how do I go back? Uh-oh, I don't know, maybe here? Yeah. So it provides information for different sectors for 2000 to 2020. There is a paper that describes all the different data sets, and these are examples, of influence of temperature on residential combustion. We discussed that yesterday and the day before, but also fertilizers, for example, that would be important, for example, for ammonia and nitrogen oxides. So what are the plans for to develop further this temporal profile at the global scale? Is to use as many data on global mobility indicators. One of them is TomTom, and there are other ones, refinements of heating degree day, and we also will use, as Hugo also mentioned, feedbacks from the CAMS global and regional modelers, because it's the only way we can improve our data set when we know what the problem or the good things you get from the models. So there will be construction of temporal profiles specific for point source facilities, an extension of the profiles up to 2023 to be in line with what is needed for the forecast, and also assess the national holidays temporal profiles, but also COVID-19. And so provide a simplification of the profiles so that they're more easily implemented in the operational models, because we will implement them in the CAMS glob ant dataset, but maybe for you, you have another dataset that you want, for which you want to use temporal profiles. So another thing that will be done in Barcelona is to construct a global point source database at the exact location for power plants, cement plants, and other facilities. And that will include also temporal and vertical profiles. And this work will be done with a COCO2 project, and we already had a few discussions about COCO2. So concerning the shapes, as Hugo also mentioned, so there will, what is available now is a 2014 to 2020 data set using activity data for using this STEAM version 3.5 model developed at FMI. And the problem is that if you were in the meeting yesterday, I showed a plot where you can see that the data from 2000 to 2013, they are used on all data. They're based on the 2016 vessel activity using a firmer version of the model. So we have quite inconsistency at some around 2014. So, and the model also doesn't include the impact of weather, like wind, waves, ice cover, and so on. And it currently is divided in for emissions from sea areas and inland waterways. So what are the plans? So the plans are first to do emission modeling, which includes the weather patterns. So like, for example, wave height and direction, wind speed, ice thickness, and so on. And the new model will also have a lot of updates, like emission factors, new ones, engine and boiler usage profiles, and already mentioned we will have methane emissions now. And we will have more information on domestic and international shipping. So sometime around December, there will be a new updated time series from 2000 to now with a new model providing daily emissions, 0.1 degree grid, and it will be much more consistent with backcasting for the previous years. So now if we go to the natural emissions, we have several data sets. So the first one is CAMS Globio, developed at University of Prague, Charles University, by Katerina Sindelarova and her colleagues. And we have different versions of the biogenic VOCs, so there are a lot of VOCs, 25 species from 2000 to 2020 at a 0.25 degree grid. It's published in this paper here, and there are different versions. So the two most recent versions are CAMS Globio version 3.1 and 3, where the main difference is that there is a version where the emission factors used in the EMEP model are also used, and this shows quite sometimes large difference in isoprene, for example, emissions, and you can see here some plot of the emissions of all these BVOCs. So what are the plans? Is to update the emission to the most recent years, but also to update input parameters, like, for example, leaf area index and emission factors, and see how we can harmonize better with other CAMS projects, include the soil moisture stress on plants and its impact on emissions. And there is a new Megan version 3 model that is under development. It's the standard model for BVOCs developed by Alex Günther at University of Irvine in the US, but many other colleagues. So when it's available, it will be also tested and used. And we also discussed that yesterday, how to really implement an online module for the calculation of BVOC's emission into the IFS. So different possibilities will be discussed, like a simplified algorithm, more complex algorithms used in other models, and same as in the ORCIDE model, and so on. So a discussion with ECMWF and CAMS 235, so the global modeling group, are planned maybe sometime in July. So then we have CAMS Globe Soil, which is the NOx emission from soil developed by David Simpson and his colleagues. So we have for now version, wrong. Yeah. We have version 2.2 that was developed in 2020, that will be updated in 2022. It uses MODIS and IGBP land cover, and plus pulsing. So because NOx emissions from soils are mostly related to pulses, depending on rain and so on. So it's a monthly resolution data set, 0.5 degree, and the emissions are provided for four different categories. And you can see a plot here, and the plans for next year. For the next months are first to improve the agricultural inputs and a finer scale for Europe because we have more data, investigate more complex functions for soil moisture effects and pulsing, and try to use, if possible, topography, because what we need to do for these NOx emissions that are extremely complicated is to try to calibrate the best against measurements, and as David says, as best as we can, so try to see if we can spot and quantify these pulses, and can we quantify the soil contribution to rural NOx levels, and look also at how we can define better emissions depending on soil moisture, soil characteristics, rainfall, and so on. So as he said, it's tricky. So then we have the volcanoes, and so this is a data set developed at Chalmers University by Santiago Arellano and his colleagues. It's published in this paper here, and where for now we have emissions of 2005 to 2019 of continuous degassing volcanoes. For now, for SO2, it's daily resolution, spatial resolution is 1 degree, and this derived from a European project called NOVAC to look at volcanoes, and gives you where you have a lot of statistics on the volcanoes. Meteorological data are used from ERA interim and ERA 5. And so what is planned also is to look at, and it started already, of CO2 and different other gases from volcanoes, and to compare ground-based and satellite, and also use satellite-based estimates from OMI and TROPOMI, and also look at different latitude, altitude, and type of volcano, and so on. So the plans for the next months is first to continue the record using data from literature, so from OMI and also from this NOVAC, a network, implement global emission combining OMI and TROPOMI and ERA 5, and go to a temporal resolution of a month and improve the spatial resolution, and also look at more explosive volcanoes, and for eruption with a specific value of explosivity, look at injection height, the duration of event, and try to get the data within 2 weeks of the eruption onset. So, and I think the last data set is CAMS Globe OCE, but oceans, developed by Michael Gauss and his colleagues at Met Norway. And so for now, we have emissions of DMS halogetin species, is version 3.1. It goes from 2000 to 2020 or 2019, depending on species, and spatial resolution 0.5 degrees. And it's based on water concentration formulas from the literature, and also on the ERA 5 Howley data. So I've put here different references that describe this data. There is also a version for OCS, and temporal resolution is monthly, and spatial resolution is 1 degree. So it's representative of 2000 to 2014, and but there is a more recent data set that you can also get. So the plans are to extend the data set for DMS and halogenated species to 2021, should be available in autumn 2022, and to improve the coefficient used and the formula used to calculate the emissions, and also calculate emission data with the Norwegian Earth system models, at least to DMS and some halogenated species. So in conclusion, you have seen that we have a lot of data sets, and we have done a lot in the past. We will do many more and updated and hopefully much better data set available. The first one will be available sometime in the fall or winter 2022 for both global and natural anthropogenic emissions. And Hugo will show that when will give a summary of the discussion. So we had very good discussions yesterday with the people using the emissions, because we really need a lot of feedback from people using this data. So, and I will finish by thanking all the different CAMS partners. We have a very nice group. And so thank you to all of you.
Thank you. There would be time for one burning question. If not, we move on to the next talk.
Leonor.
Oh, there is one. Oh.
Leonor has one.
Yes, I have a burning question.
Okay.
But wait.
Yeah, please wait for the microphone.
Yes, thank you very much. It is a burning question. No, it is not. It's not about the fires, but I want to know, and it goes both for you, Claire, and for you, Hugo, on the use of Sentinel-5P and especially Tropomi data. And it seems to me that you are using it for soil NOx and you are using it for volcanoes, but that's the only place. You are not using it for biogenic VOCs. I just want to check a bit the complementarities with the SEEDS project.
I think for biogenic VOCs, it's mostly used for now just to look at formaldehyde emissions. And concerning the anthropogenic emissions, we have no plans in CAMS, but somebody yesterday, I think it was Richard, described, future project like Cameo and Corso, and this is planned in this project to improve at least the consistency of and with observations, but not specifically in CAMS. I don't know if, Hugo, you want to add something?
No, I think that's right. So the difficulty is, of course, that if you... One microphone is enough. That we always need source sector information. And with the satellite, you don't see the source sector. So it's difficult to directly use those. You can use it in evaluation of when you put your emissions in the models and you get your columns. And so that's a very important aspect. But to directly use it, is difficult because we need this source sector breakdown for obvious reasons. Yeah, but that's like an evaluation task. So it's never, at least in my mind, it's never directly the satellite and the emissions. There's a model and there's transport in between, so.
Yeah, same for formaldehyde. I just mentioned it, but the problem is not all the formaldehyde is coming from vegetation. You have also oxidation and you have anthropogenic emissions, so